Hello everyone, in this video I am going to teach you how to delete a node from the doubly linked list. First I will teach you how to delete a node from the beginning of a doubly linked list. See, now this is the doubly linked list. This contains three parts. The structure of node contains three parts. First part is previous pointer, which stores the address of previous node. Then this is data part, you can store data value. This is next pointer, which stores the address of next node. And there are two pointers, head and tail, which stores the address of first node and last node. Now see, now first let's see the case when the linked list is empty. So see here, I am taking two pointers, head and tail. Now see, now if the linked list is empty means there are no nodes present in the linked list. If no nodes are present means you can't delete any node from that. So you can't delete. So that is the condition. You should check whether the linked list is empty or not. So see here, how you can check linked list is empty. See, head pointer is a pointer which points towards the first node, but there is no first node here. So head will have 0 and tail will point to the last node, but there is no last node. So tail will be 0. So if head and tail is 0, you can say the linked list is empty. So you can't delete any node from that. So I am writing the code here. See, if head equals to tail equals to 0, then print linked list is empty. Print empty. This is the case, printf empty. Now see, I have wrote the condition for the when the linked list is empty. Now see, now let's see the case when linked list is not empty. There are three nodes in this linked list. See, I am checking whether head and tail is 0. No, head is 100, tail is 300. So what it means? If head and tail have same value means then they are pointing at one node. Suppose head is 100 and tail is also 100 means only one node is present, that is 100. First and last node is 100, like that we can say. But head is different value and tail is different address. So that means more than one node is present. So this linked list is not empty. So what to write? See here, else condition. Now when the linked list is not empty. Now how to delete this beginning node? This is the first node, you want to delete this. How to delete? See here. Now you want to delete this node. If you delete this node, then this will be deleted, then this will be the first node. So head pointer is the pointer which stores the address of first node. So if you delete this node, head pointer will point towards this node. So see here, now this address is 200. So head I am writing 200. You can get that 200 from the next pointer of this node. So see here, head is 200 means it points towards this node. Now this node is considered as first node. Now see, now next step is, this is the previous pointer of this node. In this previous pointer I should store 0, because if I delete this node, there is no node before this node. There is no node this node. So this will be 0. So I should update this value to 0. How I can update? Head the previous equals to 0. Then see, then this link will be deleted. This link will be removed. So now see, now you have deleted, you are considering this as the first node. Now this is the linked list, you have two nodes. Now this is not considered as a node in this linked list, but see, but data is stored in this node, so there will be a memory wastage. So you should delete this node. How to delete? For deleting this node, you need to access this node. For accessing, you need a pointer, but there is no pointer pointing to this node. See, at starting head pointer was pointing to this node, but head is moved to this node now. So I need a separate pointer called temp, and temp pointer should point to this node. So before moving head pointer forward, before moving this head pointer forward, you should write temp equals to head. Then head was 100 before. So temp will be equals to 100 and temp will point towards this node. So see, I am writing the code. Then afterwards you can delete this as free temp, like that you can write. See here. Now at starting head is pointing to this node. Now head is 100. Now see. Now I am writing the code. First time I am creating a temp pointer and that temp pointer is pointing to this node. See here. Temp equals to head. Now I am creating a temp pointer and this pointer has the value which is equals to head. head is 100, so this temp is 100, so this pointer is pointing to first node. Now next step is you should move the head pointer to next node, so I'm writing head equals to head next, head equals to head next. Now see, what is head? Head is this pointer. In this pointer I am updating the value to head the next. Head is 100, 100 is this node, 100 next is 200, so I am putting 200 here. So now this pointer is cancelling and this head pointer is pointing to this node, second node. Now this is considered as first node. Now see, now this is the previous pointer of this node. In this previous pointer I should store 0 because I should consider that there is no node before this. So see here, I am writing head previous equals to 0. Now see, head is 200. 200's previous is this part. In this pointer I should store 0. So see here, I am writing 0. So this link get cancelled. This link is not pointing to 100 anymore. So this link got cancelled. Now see, now no need to write here 0. See, now this link is removed. So this is enough. No need to write 0 here. No need to cancel this link. It's a time waste. So see here, now you have considering this as first node. But see, now this is memory wastage. You have data value in it. So you should delete this node. How you can delete? See, now you have a pointer pointing to this node. So that is temp pointer. So I am writing as see, free temp. Now see, temp is 100. It's pointing to this node. So now I am freeing this node, deleting this node. So this node will be get cancelled. So now you have for the node which is at the beginning is deleted. This is how you should delete a node at the beginning of a doubly linked list. Now see, now I'll teach you how to delete a node at the end of a linked list. See, first case is I should check whether the linked list is empty or not, because if the linked list is empty, you can't delete any node from that. So this is the same condition as previous. See, if head and tail is 0, you can say it is empty. So see here, now it's checking whether head and tail is 0. No. So this linked list is not empty. Now this it goes to else part. Now see, you want to delete the last node. So how to delete it? See here. Now this is the node. You want to delete it. Suppose if this node is deleted means, see, tail, this, if you delete this node means this node will be considered as last node. This node address 200 is considered as last node. So see, tail pointer is a pointer which stores the address of last node. If this node is deleted means tail will point towards this node because this will be the last node. So the address of this node is 200. 200 should be stored in tail. So where can you get this address 200 from? 200 is stored in the previous pointer of this node. Previous pointer of this whole node. Now this whole node address is stored in 300. So see, now first I am updating this 300 to 200. So see here, now this tail pointer is cancelling and tail pointer is pointing to this node, second node. Now see, now this next pointer of this node, you should store 0, because if this node is deleted means this is the last node and there will be no node present after this node. So this will be 0. So if you update it to 0, if you are updating this to 0, this link will be get cancelled. So you are considering this as the last element. Now tail is pointing to the last node and this pointer is also updated to 0. So that you are considering that there is no node present here. But see, you have now the linked list is consisting of first node, second node. But see, now you have a data value stored in memory. So that causes memory wastage. So I should delete this node. So how to delete? For accessing this node, I need a pointer, but there is no pointer pointing to this node. At starting, tail pointer was pointing, but now tail is moved one step forward, one step behind. So see here, now I should create a temp pointer, and temp pointer should point towards this node. Now how I can access this node? So when tail was pointing at this last node at beginning, at starting when it was pointing to this node, you should write temp equals to tail. So tail was 300 before, so temp will be also 300. So temp will point towards this node. Now after moving this tail and after updating this next pointer, now you can write free temp. Then this node will be deleted. So see here, now I am writing the condition. I am writing the code. Now tail pointer is pointing to this node. Now this is 300. And this link is there. It's not cancelled now. See. Now you want to delete this node. What is the first step? You are creating a pointer called temp and temp should point towards this node. So I am writing a C. Temp equals to tail. Now what is tail? Tail is 300. 300 I am putting in temp pointer. So this pointer is pointing to this node. Now see. Now you should move tail pointer one step behind. So how to move? See here I am writing tail equals to tail previous. Now see, tail is this pointer. In this pointer I am updating the value to tail previous. Tail is 300. 300 previous is 200. So I am updating this to 200. So this pointer is cancelling and this tail pointer is pointing to the node which is having address 200. Now see, now this is the next pointer of this node. In this node I should write 0 because I should after removing this element there is no node present after this node. So I should write here 0. So I am writing the code. See here. Tail next equals to 0. Now see tail next is what? 200. Next is this pointer. In this pointer I am storing 0. So see here 0. So this link is getting cancelled. So now see. Now no need to write here 0. In the previous pointer of this node, no need to write 0. It's waste of time. It's now this linked list is considered as it contains only 2 nodes. This is simply waste. So see here. Now you want to delete this node because it causes memory wastage because data is stored in memory. So how to delete? See, I have a pointer pointing to this node. So you can write free temp. So see here. Now free temp. Now see, temp is what? 300. Now this node 300 is deleted. So this node is deleted. So see here, now you have a linked list with only 2 nodes, doubly linked list with only 2 nodes. This is how you should delete the node at the end of a linked list. Now I'll teach you how to delete a node at a particular position. See, now if the user says 2 means position is 2 means you should delete a node at second position. So this node should be deleted. That's the case. See, let's see how to do. First you should ask the user at what position you want to delete the node. So see here, I am writing the code. Printf enter position. Now if the user enters the some value, that value will be stored in position. How it can store? By using scanf function. So see here, scanf %d comma and position. Now if the user enters the value means it's stored in position. Now see, suppose the computer is asking the user to enter the position. Suppose see, in this linked list there are only 4 nodes. But if the user says delete a node at position 6, but see there is no 6th node present here, so you can't delete. So what's the case? See, I am writing that case. If position greater than count, print invalid. So see here, position is 6. Now what is this count? Count is number of nodes present in the linked list. It's a separate program. I have taught you how to count number of nodes. So see here, the 6 is greater than 4. So you can't delete 6th node from this linked list because 6th node is not present in the linked list. That's the thing. Now see, now it prints invalid. So it again goes into the statement and again asks the user to enter the position. So now see, suppose the user says position is 2. So the user should, the program should delete this second node. So this is the first node, this is the second node. You should delete this node. So how to delete? See, so in this pointer, next pointer of this node, you should store the address of next node. So if this node is deleted means the next node of 100 is what? 300. 300 will be the next node of 100 if you delete this node. So 300 will be stored in this pointer. Same way, this is the previous pointer of this node. In this previous pointer, you should have stored the address of previous node. So previous node of 300 will be 100 if you delete this node. So 100 should be stored in this pointer. After storing this, updating these two pointers, this each link will be cancelled. This link will be cancelled and this link will be cancelled. And after that you can delete this node. Because if you don't delete this node means it will be memory wastage, because data is stored in memory. So you should delete it. So how to delete? For that I should access this. I need to access this node. How to access? By using a pointer. But there is no pointer pointing to this node. So I should create a temp pointer. And see, this temp pointer can't point directly to this node. It can't directly point to any node in a linked list. For accessing this node, you need to start temp pointer at starting. It should point to the first node. Then one by one at each step temp pointer points to the second node, then third node, like that it moves one step forward. Then it stops at 200. After, when temp is pointing at 200, then temp pointer does not move to 300. So that is how you should use the temp pointer. So see here, I am writing the condition. So at starting I am creating a temp pointer and temp pointer is pointing to the first node. How you can get the address of first node? From head. So see here, else temp equals to head. Now see, head is 100. 100 is stored in temp. So this pointer is pointing to the first node. Now see, now you should move this temp pointer one step forward. But you should not continuously move till last node. You should stop at 200. So how to stop? What is the terminating condition? See here, I am writing while I less than position. Now what is this I? I is a variable which tells us at what position is the temp pointer pointing to. See, temp pointer is pointing to first node. So I will be 1. So see here, I am defining this I at starting. Int I equals to 1. This is starting. You should declare I equals to 1. So see here, I is 1. It's pointing, temp pointer is pointing to first node. Now see, now you should now check this condition whether I is less than position. I is 1, 1 is less than 2. So you should enter into this statement, that is you should move the temp pointer one step forward. So how to move? So the address of this node is 200. 200 should be stored in this temp pointer. Where can you get 200? 200 is stored in the next pointer of this node. So see here, temp equals to temp next. Now see, temp is this pointer. In this pointer I am updating the value to temp next. Temp is 100. 100 next is 200. So I am updating this temp pointer to 200. So now this pointer is getting cancelled. And to this point, temp pointer is pointing to the second node, which is having address 200. Now see, now temp pointer is pointing to second node. So I should have value 2. Because I tells us at what position is the temp pointer pointing to. So how to increase to 2? You should increase I value by 1. So see here, I am writing I plus plus. So 1 is updated to 2. Now temp pointer is pointing to second position. Now see, now again go back and check this while condition. While whether I is less than position, I is 2. 2 is not less than position 2 because they are both equal. So it does not enter into this statement, that is temp pointer does not move again one step forward. So it stops here. Now see, that's why I am writing this while condition. Now see, now temp is pointing at 200. Now you want to delete this node. How to delete? First you should remove this link. So first step is in the next pointer, this pointer of previous node, this node. You should store the address of this node because next node of 100 is 300 if you delete this node. So see here, I am writing the statement. Now in this pointer. So how to access this pointer? Now see here, I am writing temp previous next equals to temp next. Now see, in this pointer I should store the address of this node. 300 I should store here. So I am writing here temp previous. What is this? Temp is 200. 200 previous is 100. So now temp previous is 100. Now 100 next. Now 100 is this node. 100 next is this pointer. In this pointer, I should store the address of 300. Now how I can get 300? From temp next. So temp is 200. 200 next is 300. So 300 is stored here. So this link is getting cancelled. And this pointer is pointing to the node which is having address 300. So this node. Now you have removed one link. Now see, this is the previous pointer of this node 300. So in this previous pointer you should store the address of previous node. So if you delete this node means previous node of 300 is 100. So 100 you should store here. So see here I am writing the code. Temp next previous equals to temp previous. Now see how to access this pointer, previous pointer of this node, how to access. See here, temp next to previous, you should access like this. Temp next is what? Temp is 200. 200 next is 300. Now 300 is previous. 300 previous is this pointer. In this pointer I should update the value to temp previous. Temp is 200. 200 previous is 100. So this node. So I should store 100 in this pointer. So this link is getting cancelled. Now this pointer is pointing to the node which is having address 100. So this node. So see here. Now you have freed the link. Now you should write here 0. No, sorry, this pointer. You want to cancel this link. And you also want to cancel this link. So you should write in this previous pointer of temp and next pointer of temp you should write 0. But it's not compulsory that you should write 0. Why it's not compulsory? See here, if you now temp pointer is pointing to this node. So if you delete this node directly, if you free that node, the link get automatically deleted. So see here, now I should free this node because it causes memory wastage because data is stored in the memory. So see here, now to access this node, temp is pointing to this node. So I am writing free temp. Now see, temp is 200. So this node is removed. If this node is removed, this link is also deleted automatically. The value. This is how you should delete the node at a particular portion of the doubly linked list. That's all for today and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.